So very good morning to one and all gathered here. Today we are going to see friction module number 7 in basic applied mechanics. So you are going to see few numerical problems on friction. Let us see the first example. Consider block A, which is made up of steel material. The block A slides down on an inclined plane of ice in a mountain. So what is given here in the problem? You take a rigid block which is named as A, made up of steel material, which continuously slides down on an inclined plane of ice in a mountain. The angle of inclination is said to be 30 degree. The mass weight of the block is 200 kg. Block A, the mass of block A is 200 kg. The coefficient of kinetic friction is 0.02. These are the given variables from the problem statement. Determine the kinetic frictional force developed during the downward sliding of steel body over the inclined ice surface. So we want to examine the kinetic frictional force of the block A due to downward sliding over the inclined ice surface. Find the net force due to the downward direction of the inclined plane. The block slides in the downward direction of the inclined plane. What is the net force acting on the body? So these are the two objectives we want to find out. Now let us go to the solution part. So the illustration, problem illustration. Consider block A resting on an inclined plane at an angle 30 degree. Let the Fn be the normal force acting perpendicular to the direction of the applied force, where Ff is the frictional force. So here we want to resolve the force horizontal and vertical component. So if you focus the direction of force subject to horizontal means cos theta. Vertical force, if you want to resolve the force in vertical direction means sin theta. So these are the basic things that is quite applied when you are resolving the force in various directions. Now list out the different index variable. Let m be the mass of the steel body A, 200 kg. Let theta be the angle of inclination of the ice surface, 30 degree. Coefficient of kinetic friction K, 0.02. So dimension is constant. Force due to the weight of the steel body, m into g. So where m is the mass of the body, g is the acceleration due to gravity, 200 into 9.8 watt. So you will get this value, 1960 Newton. Force due to the weight of the steel body, Fw. Now find out the normal force, Fn. So force due to the weight which is acting perpendicular to the inclined plane. So we want to calculate the normal force from the given figure. So the perpendicular force, the force which is acting perpendicular normal to the direction of the applied force, it is normal Fn for normal force. So we want to calculate what is the value of normal force due to the weight which is acting on the inclined surface. So mg into cos theta. So 200 into 9.8 into cos theta. In place of theta, you put 30 degree. The plane inclination is 30 degree. So now find out the normal force value. 1697.41 Newton. So what is kinetic frictional force? So M into normal force. The M is the, sorry, here it is not M, K. K is the frictional coefficient, kinetic frictional coefficient. So K into normal force. So 0.02 into 1697.41. So kinetic frictional force is equal to K into Fm. It's not M. Please make a note of it. Friction due to the weight of the body along the downward slope of the inclined plane. So Ft is the downward force which is acting along the slope of the inclined plane. So mg into sine theta. So 200 into 9.8 into sine 30. So 980 Newton. We want to find out what is the net force. So by finding the difference between the downward force minus frictional force, kinetic frictional force. So you will get the net force 946.05 Newton. So here, this problem, we want to find out what is the net kinetic frictional force that is placed on a body which is sliding down across the inclined slope. So for that, we want to calculate what is the downward force, the frictional force due to kinetic energy. So they have given the mass value. From that, we want to find out the resolving of force into horizontal vertical component. From that, the total final net force can be evaluated. Next example, consider a box with mass M is kept on a horizontal table. It is being pulled rightward by inclined pulling force P with an angle theta with the horizontal axis. Draw the free body diagram for this case. So what is given in the problem? Let M be the mass of the rigid body lying flat horizontal to the surface. Take a force P which is acting at an angle theta with reference to the horizontal axis. Okay, so we want to draw the free body diagram for this case. So draw the free body diagram. So F will be the normal force, M into G, that is nothing but the force which is acting downward due to the weight acting on the surface. P be the applied load which is inclined at an angle theta. Ff is the frictional force. Now we want to resolve the force horizontally and vertically. Before that, let us fix up the variables, parameters to be listed. Let M be the mass of the box, M into G force due to the mass of the box, T is the inclined pulling force, theta angle of inclination of the force P with x-axis, Fn be the normal force, Ff is the frictional force. Now resolving the forces with respect to the x direction, summation of fx is equal to 0. Okay, so from the free body diagram, so P cos theta, resolving the force x towards x direction. So applied load is P into cos theta minus Ff. The frictional force is located in the opposite to the applied load. So this to be taken minus negative. So P cos theta minus F suffix F is equal to 0. So this can be rewritten as frictional force is equal to P into cos theta. Now resolving the force towards y direction. So refer the free body diagram. Fn normal force Fn minus mg. So mg is the force due to the weight acting on the box which is located in downward direction. So put minus Fn minus mg plus P sin theta is equal to 0. So take Fn the left side. So find out the normal force. Fn is equal to mg minus P sin theta. So these are the two equations, frictional force and normal force. So now find out the acceleration due to gravity of mass in x and y direction. So we know that Newton's second law of motion F is equal to m into a. So from that equation, okay, so mass due to acceleration towards x, m into ax is equal to p cos theta minus frictional force F suffix F. So bring ax the left side. Ax is equal to p cos theta minus frictional force divided by m. M is the weight of the body. Similarly, m into ay, where ay is the acceleration towards y direction, is equal to Fn minus mg plus p sin theta. So ay is equal to Fn minus mg plus p sin theta by m. So ax and ay are the acceleration due to gravity with respect to x and y direction are related here. So in this problem, just we have drawn the free body diagram of the rigid block and we discuss about how to solve the forces horizontally and vertically, find out the frictional force and normal force with respect to the resolving of force component, then estimate the acceleration due to gravity based on the weight which is placed on the rigid body subject to x and y direction. So with this a few little introduction, I thank each and every one of you for your kind support. So in the next meeting, we will see somewhat new other topic related to the latest new age technological concepts. So thank you very much. If you have any comments, you can share in the YouTube channel link. So thank you very much.